Good morning, dear student. In today's lecture, we are very much interested in the important point of our syllabus of our chapter, that is magnetic material, in which we discuss the magnetization. So, what is this magnetization? In previous lecture, we already discussed some important definitions. What is magnetism and uh, different properties of magnetic material. So, what is magnetization? And we will discuss some important numericals which is asked in your exam uh, to find out the saturation magnetization or to find out the magnetic moments if the magnetization is given. So, let us discuss this magnetization. Magnetization of a material is defined as, so if we consider its definition, magnetization is defined as magnetization is defined as the magnetic dipole moment magnetic dipole moment induce induce per unit volume per unit volume of material per unit volume of your material. So, what is this magnetization? Magnetization is defined as the magnetic dipole moment induced per unit volume of the material. In other words, we can say that it is the ratio of net magnetic dipole moment per unit volume of the material. That is the ratio of. So, this magnetization, it is the ratio of this magnetization. If we consider, it is an a vector quantity, it gives direction, so it can represent as capital M vector. Magnetization, it is the ratio of net magnetic net magnetic dipole moment net magnetic dipole moment per unit volume of material. So volume of material so net magnetic dipole moment divided by the volume of material. So this net magnetic dipole moment, it is denoted by symbol small m, and it is a volume, that is the volume of the material. And if you consider its unit, that is what is the unit of magnetization, if you consider this net magnetic dipole moment having a unit of ampere into area, and we know the unit of volume is volume, it is in meter cube. Volume, it is in meter cube. Okay, so and we know that the area having unit of meter square, so it becomes this net magnetic dipole moment having unit ampere into area, and the unit of volume is meter cube. The volume is in meter cube of solid material, and therefore it is ampere. Area, it is in meter square divided by this is in meter cube. So if we find out this, or if we solve this, then we get this, that is ampere per meter. So this is the unit of magnetization. So what is this magnetization? Magnetization is defined as the magnetic dipole moment induced per unit volume of a material. So it is the ratio of net magnetic dipole moment to the volume of material. So the net magnetic dipole moment having a unit of ampere into area, it is in meter square, ampere, that is in current, ampere, the unit of current is ampere, and the volume, that is the unit of volume is whatever the volume of that of material, that is magnetic material, it is expressed in meter cube. And if we solve it, then we get ampere per meter, ampere per meter. So you should keep in mind this magnetization, it is an vector quantity, it gives direction, and therefore we can represent it is as capital M vector. So let's discuss some another definition of this magnetization. What is this magnetization? Let's discuss it. That is, if you consider this magnetization is also defined as the process of making the process of making the process of making a substance or a solid material, the process of making a solid material temporary, a solid or substance, the process of making a solid or substance temporary or permanently or permanently temporary or magnetic permanently magnetic as by insertion in magnetic field, as by insertion in magnetic field, or by the application of external magnetic field. By the application of external magnetic field is called magnetization. Is called magnetization. So this is the other definition of this magnetization: the process of making a solid or any substance temporary or permanently magnetic. So the process of making a solid or any substance temporary or permanently magnetic by the application of external magnetic field is called magnetization. Or in other word, we can also express what is this magnetization: the extent to which the extent to which the extent to which an object means solid or any substance, solid material or any substance, the extent to which an object is magnetized the extent to which an object is magnetized is called magnetization. The extent to which the object is magnetized is called magnetizations. So how much magnetic lines of force are passes through this material, okay, is called as magnetization. The extent to which an object is magnetized is called magnetization. Or the process of making a solid temporary or permanently magnetic by the application of external magnetic field is called magnetization. Or it is defined as the magnetic dipole moment induced per unit volume of the material. Or we can also define as this magnetization of a solid is the sum of magnetic moment in unit volume of the solid. Magnetization of a solid is the sum of magnetic moment is the sum of magnetic moments in unit volume of the solid, in unit volume of the solid. So you should keep in mind this definition, the process that is the phenomenon that is magnetization. So let's discuss one numerical on this magnetization. So many times this numerical is asked in exam. Let's discuss it. So we know that magnetization, it is the ratio of net magnetic dipole moment to the volume, and its unit is ampere per meter. The numerical is What is given? They given the saturation magnetization. Saturation magnetization is given. Saturation magnetization of BCC, body center cubic lattice. BCC, body center cubic lattice iron, for iron is 1750 kilo ampere per meter. Calculate the net magnetic moment. Calculate the net magnetic moment. Calculate the net magnetic moment per iron atom, for each iron atom, for iron atom, per iron atom in the crystal, and what is given? The given the lattice parameter is given, that is edge length is given. A lattice parameter is given, the lattice parameter is given. Lattice parameter is given for PCC, that is A, which is equal to 2.87 angstrom. 2.87 angstrom. So such a kind of numerical is asked in exam many times. They gives saturation magnetization for BCC made up by iron, that is 1750 kilo ampere per meter. Calculate net magnetic moment per iron in the crystals, given the lattice parameter, that is A, which is equal to 2.87 angstrom. So let us, we know that what is given, that is magnetization is given, saturation magnetization, or we can consider is in magnetization. So m vector it is given, but it has a unit of it is given as 1750 kilo ampere per meter, but we know that its unit is ampere per meter. So I have to convert this kilo into only I have to remove this kilogram, so you have to multiply this 1750 into 1000. So what you get here, we get only ampere per meter. So this is the first one. Then the second, that is lattice parameter is given. Lattice parameter is given. Lattice parameter, that is A is given, edge length is given, that is 2.87 angstrom is given. And we know that we required, what we required for to find out the magnetization, we required the net magnetic moment. We required the net magnetic moment, and we required the volume. We required now in this case we have to find out the net magnetic moments. So the saturation magnetization is given, how to find out the net magnetic moment. So the net magnetic moment can be find out, so we know the formula, that is magnetization which is equal to net magnetic moment divided by the volume, so this value is there, you have to find out volume, and then we can easily find out the net magnetic moment. Therefore we can write the net magnetic moment is equal to net magnetic moment, which is equal to net magnetic moment is equal to the magnetization into the volume of the cube, that is volume of BCC. So the magnetization is there, that is 1750 into 1000, but we required the volume, and it is per metal atom. So if you consider to find out the volume, so what they gives, they give you the edge length, that is lattice parameter is given. lattice parameter, that is your 2.87 angstrom. 2.87 angstrom. So what is this lattice parameter, or how will you find out the volume of the cube? So you should keep in mind the volume of the cube, which is equal to cell edge length cube, cell edge length cube. So whatever the volume of the cube, which is equal to cell edge length cube, and this lattice parameter is nothing but your cell edge length. Cell edge length, that is the length between two corners of the unit cell. So what is this lattice parameter? It is the length between two corner. It is the length between two corner of the unit cell, and volume of the cube, which is equal to cell edge length. This lattice parameter, it is also known as cell edge length, and the volume of the cube, which is equal to cell edge length cube. Cell edge length cube. The lattice parameter, it is also known as cell edge length, and the volume of the cube, which is equal to cell edge length cube. So whatever the cell, that is BCC, whatever the edge, that is 2.87 angstrom, the length between two corners is called cell edge length. It's called cell edge length. It is also called as lattice parameter. And to find out the volume, you have to make its cube. To find out its volume, of the cube, you have to convert this volume, that is lattice parameter, to make its cube. So what you get here, and it is unit, its unit is, if you consider the unit of volume is meter cube, and the lattice parameter given in angstrom. So you have to convert this angstrom into meter cube. So you have to convert this angstrom into meter cube. So first you have to make a cube, that is 2.87 into 10 raised to 3, 2.87 into 10 raised to 3 multiply 10 raised to minus 30 meter cube. So you have to first convert this value, that is 2.87 angstrom, to convert this value into angstrom. To convert this angstrom value into meter cube, you have to multiply by 10 raised to minus 10 and then make its cube, because we know that the volume of the cube is nothing but the cell edge length cube. So cell edge length is given 2.87, so make its cube, and this angstrom unit is converted into meter cube. Therefore the angstrom, one angstrom, if you consider the angstrom, which is equal to if you convert this angstrom, then you have to multiply by 10 raised to minus 10 meter, and then make its cube, that is 10 raised to minus 10 multiply by 3. So we get 10 raised to minus 30 meter cube. So there is a conversion of angstrom into meter cube. So keep in mind, so whatever the volume of the cube, which is equal to cell edge length cube, so whatever the lattice parameter given, you have to make its cube and convert this angstrom unit into meter cube by multiplying the proper factor. And then the next important point is that you have to find out the net magnetic moment per metal atom, So if you consider this BCC, body center cubic lattice, we know that we are very much familiar with this BCC. In BCC, there is a one atom at center and remaining atoms at corner. So if you consider the BCC, and if you find out the total number of atoms in BCC, then we know that total 8 corner is there, and it having a contribution 1 by 8. And if you find out the number of atoms at corner, so this is the formula for number of atoms at corner. So total 8 corner is there, and its contribution is 1 by 8. Its contribution is 1 by 8. So total 1 atom at corner. So what you get here, total 1 atom at corner. Total one atom at corner. And if you find out the number of atoms at center, so there is only one atom and its contribution is also one. So total one, if you consider total one center is there, okay, and their contribution is one, so total one atom is there. And if you find out, okay, so one atom at corner and one atom at center, and if you add it, then there is a total two atoms, then there is a total two atoms in this BCC. So we are very much familiar with this simple cubic lattice, body center and face center. In simple cubic there is only one atom at the corner. There is only one atom at the corner because total 8 corner is there and total contribution of this corner is 1 by 8. The contribution of this corner is 1 by 8, so number of atom is 1. In BCC, the corner having one atom and the center having one atom 2. In FCC there is a total 4 atom. So you have to find out net magnetic moment per atom, per iron atom. So you have to multiply. We know that there is a 2 iron atom, 2 iron atom net magnetic moment per atom. So in this case 2 iron atom, so you have to find out net magnetic moment per atom, so you have to divide this value by 2, divide this value by 2 to get net magnetic moment. And if you solve it, then we get it 2.06 into 10 raised to minus 23 ampere meter square, ampere meter square. So you should remember, whenever the whenever the problem is given, first you have to think about unit. So whatever the value is given, either saturation, magnetization or magnetic moment, first convert the unit, because the unit conversion is very important, and then we can easily solve this numerical and easily find out the net magnetic moment per atom. So per the number of atoms in unit cell you should keep in mind. For simple, that is 1, for BCC it is 2, and for FCC it is 4. The volume is easily find out, the volume of the cube is easily find out by the cell edge length cube, and the cell edge length is nothing but your lattice parameter. So this is all about the magnetization. In next lecture we will discuss the remaining points of our chapter, that is magnetic material. Thank you.